What if I told you something crazy? Right now, like literally right now while you're watching this, there are cyber criminals actively trying to break into networks all around the world. And there's this entire invisible army of security professionals fighting them off 24/7 using two technologies that honestly most people have even never heard of. Hello everyone, I'm Sasindu. I'm in my final year studying cybersecurity. And look, when I first heard about SIEM and SOC, I was so confused. Like, what even are these acronyms? But here's the thing, these two concepts, they are literally the backbone of modern cybersecurity. Every major company you can think of, Google, Microsoft, your bank, even your university, they all rely on SIEM systems and security operation centers to keep their data safe. So today, I'm gonna break down exactly what these things are, how they work together, and why understanding them is super important if you are getting into IT or cybersecurity. We will also look at some really cool technologies like the elastic stack and the MITRE attack framework. These things are literally shaping the future of security operations. By the end of this video, you will understand these concepts well enough to impress in any cybersecurity interview or class discussion. So let's jump right in. Alright, let's start with SIEM, that's Security Information and Event Management. Now, think of SIEM like this. Imagine you have a super intelligent security guard who never sleeps, and this guard can watch thousands of cameras simultaneously. But instead of cameras, it's monitoring every single digital activity in your organization. So basically, SIEM combines two things: security information management, which is like having a massive filing cabinet for all your security data, and security event management, which is the smart part that actually analyzes what's happening in real time. The National Institute of Standards and Technology, they define it as an application that provides the ability to gather security data from information system components and present that data as actionable information via a single interface. That's mouthful, right? But what it really means is one dashboard to rule them all. Okay, so here's how SIEM actually works in practice. It has three core functions. First, log management. SIEM tools are like data vacuum cleaners. They suck up event logs from everywhere. Your firewalls, servers, laptops, phones, your cloud services, literally everything that creates digital footprints. These collection agents, they deployed across your entire infrastructure. Second, event correlation and analytics. This is where magic happens. All the data, it gets normalized, meaning it's converted into a standard format, and then algorithms and machine learning processes start looking for patterns. It's like having a detective who can instantly connect dots across millions of clues. Third, incident monitoring and security alerts. When the system spots something suspicious like multiple failed login attempts from weird locations or malware signatures, it categorizes these events and generates alerts for security teams to investigate. Now, you might be wondering, why can't we just use regular antivirus software? Well, here's the reality. The modern cyber attacks are sophisticated. They might start with a phishing email, then move laterally through your network, steal credentials, and exfiltrate data weeks later. No single security tool can see this entire attack chain, but SIEM can. So you are setting up a SIEM system. It's not just installing software and call it a day. It's actually quite complex. And honestly, this is where a lot of organizations struggle. You need several critical components. First, data source identification. You gotta figure out what regulations apply to your industry. Are you dealing with GDPR in Europe, HIPAA for healthcare, PCI DSS for payment processing? Each has specific login requirements. Then you identify every single system that needs monitoring. Firewalls, intrusion detection systems, endpoint security tools, authentication systems, application logs. It's like making a comprehensive inventory of your entire digital ecosystem. Second, SIEM selection. This is where things get interesting. You are evaluating solutions based on functionality, scalability, ease of use, integration capabilities, and of cost. Most organizations do proof of concept testing because choosing the wrong SIM it's expensive and painful to change later. Third, implementation planning. This is the final component. You are outlining scope, timeline, integrations, customizations. This is not a weekend project. We are talking months of planning and optimization. For deployment, you've got several options. Traditional software solutions, hardware appliances, or modern managed services. The trend now, cloud-based solutions, because they are more scalable and cost-effective. There is fully managed SIM where a third-party vendor handles everything. SaaS SIM for cloud-native environments. Co-managed SIM, which is a hybrid approach, or fully hybrid deployment combining on-premises and cloud components. Here's something really cool. Companies like Elastic, they use distributed SIM architectures. They run 7 different clusters, 6 data clusters with different roles, and one search head clusters that queries all of them. This gives you fault tolerance, granular access control, scalability, and optimized resource allocation. Pretty smart, right? Now let's talk about the latest technologies. The stuff that's making SIM systems incredibly powerful in 2024. First one is the artificial intelligence and machine learning. This is where SIM gets really exciting. AI-driven tools. They can analyze massive amounts of data in real time, identifying threats with accuracy and speed that humans simply can't match. And they are not just detecting known threats, they are predicting potential attack vectors, enabling proactive defense strategies. Second one is the behavioral analytics. Instead of just looking for known bad signatures, modern SIM systems establishes baselines of normal user and entity behavior. When someone starts acting weird, like accessing files they never touch or logging in from unusual locations, the system flags it immediately. Third one is the user and entity behavior analytics. This takes behavioral analytics even further. It uses machine learning to spot zero-day threats and insider attacks that traditional signature-based detection would completely miss. Fourth one is the security orchestration, automation, and response, also known as SOC. This is game-changing. Instead of just alerting humans, modern SIM systems can automatically respond to threats using predefined playbooks. Imagine a system that detects a malware infection and automatically isolates the affected machine, updates firewall rules, and initiates incident response procedures, all within seconds. Fifth one is the extended detection and response, also known as XDR. This unifies multiple security products for improved threat detection across your entire attack surface. Endpoints, networks, emails, cloud environments, everything's working together seamlessly. And here's something really cool. We are seeing cloud native architecture becoming the standard. Modern SIM platforms leverage elastic cloud storage and data lakes, making them infinitely more scalable than traditional on-premise solutions. Now let's shift gears. Let's talk about SOC, Security Operations Center. If SIM is the brain, then SOC is the entire nervous system of cybersecurity. A SOC is basically a 24/7 centralized command center where cybersecurity professionals continuously monitor and protect an organization's digital assets. Picture a high-tech control room, multiple screens showing real-time security data, and teams of analysts working around the clock to keep the bad guys out. The SOC team structure typically includes experienced threat hunters and SOC analysts. They are seasoned IT security professionals who can distinguish between normal activity and hidden threats. They are like digital detectives, with the skills to identify and counter common attack techniques used by cybercriminals. SOCs use a hub and spoke architecture, and they are responsible for monitoring and protecting several critical assets: intellectual property, personal data, business systems, and brand integrity. Here's why organizations absolutely need SOCs. Corporate IT teams. They are usually work 9 to 5. But guess when most cyber attacks happen? After hours, weekends, holidays. Basically when nobody's watching. SOC teams provide that continuous protection and respond to threats immediately, any time of day. Let's be real about why SOCs aren't just nice to have. They are absolutely essential for modern organizations. SOC teams have the expertise to identify hidden threats that automated tools might miss. They can spot patterns and anomalies that indicate sophisticated multi-stage attacks. Also, when incidents occur, having a SOC ensures coordinated response from one centralized source instead of chaotic, disjointed response from different departments. This makes it easier to monitor, evaluate, and report on security actions. Also, security breaches are incredibly expensive. We are talking about reputational damage, operational disruption, legal fees, regulatory fines. SOC teams help prevent or mitigate these losses, often resulting in a positive return on investment that far exceeds their operational costs. Modern SOCs provide several key operational benefits: reduced mean time to detection, faster identification through continuous monitoring, improved incident response, streamlined processes and automated workflows, compliance support, maintaining regulatory compliance through continuous monitoring, and threat intelligence integrations. SOCs use cutting-edge technologies. AI and machine learning analyze vast amounts of data in real time, identifying threats with unprecedented accuracy and speed. XDR unifies multiple security products across endpoints, networks, email, and cloud. Zero Trust architecture enforces strict access controls. Never trust, always verify. Every access request is validated. EDR, also known as Endpoint Detection and Response, provides detailed visibility into endpoint activities. If a laptop gets infected, the system sees what happened and automatically contains the threat. Cloud-native SOC operations offer enhanced scalability and flexibility. Here's where things get interesting. SIEM systems and SOCs don't just coexist, they are completely integrated. SIEM provides the technology foundation. SOC provides the human expertise. Think of it like this. SIEM is the high-tech car. SOC is the skill driver. For data aggregation, SIEM collects data from multiple sources and presents it, so SOC teams can understand and act on it. For real-time monitoring, SIEM monitors security data and generates alerts. SOC analysts prioritize and investigate them. For event correlation, SIEM correlates data from different sources to identify complex attacks. SOC teams use this to understand the bigger picture and predict what attackers might do next. For incident response, SIEM identifies incidents and triggers response protocols. SOC teams manage the entire process from start to finish. For threat hunting, SOC analysts use SIEM tools for proactive hunting, analyzing historical data to identify threats that slip through initial detection. Let me tell you about the Elastic Stack, one of the most popular SIEM implementation. The Elastic Stack has three core components. Elasticsearch is a real-time search and analytics engine. It handles massive amounts of data and performs complex searches quickly. Logstash is your data processing pipeline. It ingests data from various sources, transforms it, and sends it where you need. Kibana is the visualization layer, the dashboards and charts that make data understandable. What makes Elasticstack suitable for SIEM is its distributed architecture. It can scale to handle enormous volume of log data and perform real-time analysis. Elastic Security combines SIEM capabilities with endpoint security in one platform. The security area in Kibana includes pre-built detection rules for common threats. You can create custom rules for specific scenarios. Now let's talk about the MITRE ATT&CK framework. This is the universal language that cybersecurity professionals use to talk about threats. MITRE ATT&CK is a globally accessible knowledge base of adversary tactics, techniques, and procedures. Based on real-world observations, it's like an encyclopedia of how cyber attacks actually work. The framework organizes attack techniques into 14 major categories. For each technique, the framework provides detailed information, procedure examples from real attacks, mitigation strategies, detection methods. Here's why this is valuable. Instead of every security team describing attacks differently, everyone uses the same standardized language. When someone says like this, that's spear phishing with malicious attachment. Every cybersecurity professional knows exactly what they mean. MITRE attack makes SOC and SIEM operations more effective. For SOC integrations, analysts classify alerts according to attack techniques. This helps them prioritize responses and understand attack progression. For SIEM integration, modern SIEM platforms automatically map detected tactics to the attack framework. Security teams use attack techniques to develop detection rules. For threat hunting, attack provides structured methods for proactive hunting. Instead of randomly looking for threats, analysts systematically hunt for specific techniques that adversaries use. The three-part approach: MITRE attack framework, SIEM software, SOC operations creates comprehensive security ecosystem. Organizations get better threat intelligence correlation, improved communication using a common language, and enhanced compliance support. The convergence of these technologies enables organizations to detect, understand, and respond to sophisticated cyber attacks more effectively than any single component alone. Let's wrap this up. Here are the key takeaways. First, SIEM systems are the intelligent backbone of cybersecurity. They collect, correlate, and analyze security data to detect threats in real time. Second, SOCs are the human-powered command centers that provides 24/7 monitoring and response capabilities. Third, modern technologies like AI, machine learning, and behavioral analytics are making SIEM and SOC operations more powerful and automated. Fourth, the Elastic Stack provides a popular open source foundation for building SIEM capabilities. And finally, the MITRE attack framework gives everyone a common language for understanding and defending against cyber threats. Understanding these concepts is crucial if you are getting into cybersecurity or IT operations. These are the fundamental building blocks of how organizations protect themselves. If you want to dive deeper into incident response, check out my previous video on how to handle ransomware attack. In that video, I break down the 5 core functions: identify, protect, detect, respond, and recover. It is the perfect companion to what we covered today. If this helped clarify SIEM and SOC concepts for you, smash that like button and subscribe for more cybersecurity content. Drop a comment and let me know which topic you'd like me to cover next. Thanks for watching, and I'll see you in the next video.